continent isn't cut in half by accident. It is surveyed, it is blasted, it is dredged, and it is conquered for one single purpose: to rewrite the map of the world. This isn't just about digging a ditch between two oceans. This is industrial warfare against geography. It is a machine made of concrete and steel, stretching 50 miles across a hostile jungle, designed to lift 50,000-ton ships over a mountain range. The Panama Canal is far more than just a waterway. It is one of the supreme achievements of the industrial age, a project that demanded the removal of over 200 million cubic yards of earth. Before its completion, a ship traveling from New York to San Francisco had to navigate the treacherous Cape Horn, a journey of 13,000 miles. The canal slashed that distance to just 5,000. But every engineering marvel starts its life not as a blueprint, but as a problem. And initially, this problem seemed unsolvable. The French attempted it first in 1881, led by the builder of the Suez Canal. They treated it like a digging project. They failed. 20,000 men died, and the jungle reclaimed their machines. When the United States took over in 1904, they understood something crucial. Steel isn't enough. You need a strategy that encompasses medicine, logistics, and heavy industry working in perfect synchronization. Before a single yard of concrete could be poured, the workforce had to survive. The French failure proved that the greatest enemy wasn't the rock, it was the mosquito. Yellow fever and malaria were decimating the labor force. So the first stage of construction wasn't engineering the land, but engineering the environment. This was a military-style campaign against an insect. Colonel William Gorgas implemented a sanitation infrastructure that was unprecedented. Swamps were drained, brush was cut back. Pools of standing water were oiled to suffocate larvae. It was a logistical operation as complex as the excavation itself. This effort reduced the death rate from tropical disease to a fraction of what it was under the French. It turned the canal zone from a graveyard into a functional industrial base. With the workforce secured, it was time to address the spine of this beast, the culebra cut. Let's talk about the skin of this beast, or rather, how to tear it open. The plan was not to dig a sea-level trench, but to create a bridge of water. To do that, they had to slice through the continental divide. This is the culebra cut. This wasn't about brute force anymore. This was the dawn of mechanized earth-moving. The Americans brought in the heavy artillery, 95-ton Bucyrus steam shovels. These monsters could scoop up 8 tons of rock in a single bite. They didn't just dig, they devoured the mountain. But digging is useless if you can't move the spoil. The efficiency of the canal relied on the railway. A complex system of tracks was laid along the cut, shifting constantly as the work progressed. It was a conveyor belt of dirt. Trains ran continuously, hauling millions of tons of debris to build breakwaters and dams miles away. Yet the earth fought back. The geological instability of the region caused massive landslides, bearing months of work and hours. The steam shovels would simply dig them out again. Failure is not just allowed here, it's expected, because stopping meant defeat. They kept digging until the cut was 9 miles long and deep enough to float a battleship. So what moves the ships through this channel, it's not about winning a drag race. It's about pure, unstoppable hydraulic power. The genius of the American plan was the decision to dam the Chagres River. By building the Gatun Dam at the time, the largest earthen dam in the world, they created Gatun Lake. This isn't just a scenic body of water. It is the battery that powers the entire system. The lake sits 85 feet above sea level. Ships don't sail through the canal at ocean level. They are lifted up to the lake, sail across the spine of the continent, and are lowered down the other side. This incredible power is what allows a 50,000-ton vessel to cross a mountain range, and it does it without a single mechanical pump. The entire system is gravity-fed. The water from Gatun Lake rushes down through massive culverts tunnels, large enough to drive a train through to fill the locks. It is nature itself, harnessed by concrete, doing the heavy lifting. Of course, a lake is useless without a way to get ships up to it. That is the job of the locks. Gatun, Pedro Miguel, and Miraflores. These are the elevators of the maritime world. Constructing them required a new era of industrial material, concrete. Over 4 million cubic yards of concrete were poured. Every single section of these walls is precision engineered to withstand immense pressure. Then there are the gates. These hollow steel structures are 7 feet thick and stand over 6 stories high. Yet they are so perfectly balanced that they can float on the water, reducing the stress on the hinges. A 40-horsepower motor barely enough to run a small car is all that is needed to open them. But what keeps the ship from crashing into these delicate gates? That's the job of the mules. These electric locomotives run on tracks alongside the locks, using steel cables to center the ship and guide it forward. It is a delicate ballet performed by thousands of tons of steel. Finally, the moment of creation arrives. The first transit. On August 15, 1914, the SS Ancon made the historic journey. What emerged from the jungle was not just a machine. It was a testament to industrial will. The total cost was $375 million, the most expensive construction project in U.S. history up to that time. But the result was a geostrategic asset that changed the world economy. It allowed the United States to become a two-ocean naval power and revolutionized global trade. The Panama Canal remains a marvel of engineering. It is a static, unmoving mountain of concrete that moves the world. It was designed, it was tested, and it was hardened for one single purpose: to connect the oceans. And that is how the Panama Canal was built. Thanks for watching, and if you found this interesting, don't forget to like and subscribe for more deep dives into the world of technology and engineering. See you next time.